I'm Eric Peter, one of the product managers on our Mosaic AI platform team. I'm here today to talk to you about Retrieval Augmented Generation, or RAG. What is RAG? RAG is one of the most popular design patterns for generative AI applications today. RAG is required if you want to connect your real-time business data to customize your generative AI application. Now, RAG apps are real-time, batch, and streaming. On the left, real-time apps, this is the most popular form of RAG. An example here is a chatbot that can answer questions about your policies. However, some applications are also batch and streaming. For example, perhaps a pipeline that updates a questionnaire every time new documents about a customer are uploaded. Let's go through an example of what RAG is under the hood. A common use case we've heard from our customers is they want to build a bot to help customer support reps find answers faster. In fact, we at Databricks also have this use case and have built a similar bot. So I'm going to walk you through the simplest architecture in order to build a bot that could answer questions like, why would a data engineer want to use DLT? So first, the question comes into a chain orchestrator. The chain orchestrator is the hub or the brain of your AI system. It then uses an embedding LLM to embed the question to understand its semantic intent and meaning. That is then passed to a vector database, which has been preloaded, in our case, with the Databricks documentation. Relevant docs are returned. Prompt engineering is used to prompt a foundational model with the user's question and these relevant docs. And then it's passed to an instruction following LLM. The response is then returned back to the user. Now, this is the simplest example, and most production RAG applications are more complicated than this, but hopefully this helps you understand the high level of the pattern. Now, in talking to the thousands of customers that are doing RAG on our platform today, what we've heard is that their biggest challenge is accuracy. This is not to minimize the challenging data prep process, the challenging productionization process, or the challenges with getting governance in place around their applications, but rather that getting high quality RAG applications is incredibly difficult and is often a blocker to putting these applications into production and ultimately seeing business value from these solutions. Why is it hard? Well, first, folks are unsure what are the right ways to measure and evaluate bot accuracy. They're unsure how to get enough human feedback to understand if their bot is answering correctly or not. Third, it's difficult for them to use the feedback to actually improve the accuracy of the bot and have fast loops to reduce its hallucination. Finally, once you have a quality bot, how do you make sure that it doesn't accidentally go unhinged and talk about a competitor or say a bad word to one of your customers? How do you put guardrails in place? Our belief here at Databricks is that RAG quality is a systems problem. Now, model quality, of course, is important, but model quality is not sufficient to have a high quality RAG application. We believe it's one part, how do you prepare your unstructured and your structured data? It's one part, which foundational and embedding models do you use, off the shelf or fine-tuned? And it's how you compose your RAG chain, everything from how you understand the user's query to how you do retrieval and re-ranking, how you prompt the model, how you post-process it, and what guardrails do you have in place. This is, again, a simplified diagram. There's a lot more complexity under the hood, but this is how we're thinking about the RAG quality problem here at Databricks. So today, I'm really excited to announce the private preview of new capabilities on Databricks, our best-in-class workflow and evaluation tools for building high-quality RAG applications. These tools and workflow are tightly integrated with the rest of the data intelligence platform, with our popular MLflow open source tools and the Mosaic AI capabilities. This offering, it provides out-of-the-box access to the cutting-edge research that's happening in our Mosaic research team, specifically around how to improve the quality of your application. I'll talk more about this in a second. Now, let me quickly go over our approach before I hop into a demo of these capabilities. So first, our tools enable a fast developer velocity. This lets you experiment quickly with different settings to find the optimal ones that drive quality in your application. Two, we make it really easy to collect feedback so you can understand how well your application is performing. Three, we make it easy to measure quantitative metrics with that feedback so you can compare different versions of your application on quality, cost, and latency. Now, these capabilities that I mentioned, you have two ways that you can use them. First, you can use our entire workflow tightly integrated and embedded with the rest of our Mosaic platform. Or if you already have an existing RAG application or you prefer using your own developer workflow, you can use our evaluation and LLM judge components, which I'll talk about shortly, separately with the logs of your application. With that, let's go ahead and hop into a demo. So one of the questions that I often get is, well, what research is the Mosaic team working on? And honestly, I wanted to have a way for people inside Databricks to be able to ask questions of what our Mosaic team was doing. So what I'm going to build today is a bot that takes a set of PDF files, the recent papers published by our research lab that are stored in a Unity catalog volume, and I'm going to turn them into a RAG chatbot. So first, I need to create a vector index. Now, this is incredibly simple on our platform. What I've done beforehand is I built a data pipeline to take these documents, these PDFs, pull them from the UC volume, parse them, chunk them, and put them into this Delta table. Now, how do I create a vector search index? It's incredibly simple. Any Delta table inside your Databricks platform can be turned into a vector search index with a click of a button. You click Create Vector Search Index, you tell us the name, choose the key, choose your endpoint. In this case, I've already computed embeddings, but you can have us also compute the embeddings for your application here. You can do triggered or continuous. This is also available through an API if you prefer to run it in CI/CD or from a notebook. In the interest of time, I already created this vector search index, which you can see here is online and synced with that chunk table I showed you a second ago. Now, I need to create the chain, or the brains of my application that I mentioned before. With our tools, you can use one of the popular open source frameworks, such as LangChain, or you can write your own Python code. In this case, I've pulled one of our examples for a chat over PDF files and have a very simple chain here. The important thing that I want to call out is this right here. We give you a way to parameterize your chain. Now, this is important, and I'll show you why later, but specifically, it helps you quickly iterate on different settings to improve quality. So in our case, I've linked in the vector index that I built. I've indicated which embedding model is being used, and I've put in a prompt for us to use. I'm going to use Azure OpenAI, but I could have used any model that's hosted on Model Serving, one of our foundational open source models, OpenAI, or any of the other proprietary LLMs out there. I'll switch that back over to my notebook now. Here, I'm going to go ahead. I'll run the chain just to make sure it works. This is the same as debugging any Python code. And then what I'll do, once I've verified that it works locally in the notebook, I'm going to log the chain to Unity catalog. So in this case, I'm logging a version of the chain with the configuration file I showed you and the code of it here. This is stored and governed just like any asset in your Unity catalog. Next, I'm going to deploy the chain. Now, this is important. There's actually a lot of complexity that's happening under the hood once we deploy the chain, but it's all abstracted into this simple command. We stand up a REST API. We stand up a review application so your end users can access the chatbot, and we enable online monitoring and metric measurement throughout the entire chain. Let me dive in and show you exactly what that looks like. So first, let's go ahead and just try that. Now, one of the recent papers that came out is called Aries. So let's ask, what is Aries? Now, Aries is a system that evaluates reading comprehension and generation. The bot's hallucinating a little bit here. So I can look and try to figure out why. I can see what sources. Does it have the right sources? What is this paper? Well, this is, I can tell, this is the Aries paper. So the bot is just hallucinating and not staying faithful here. So in this case, I'll say, no, this was not a good response. Now this is important because you can share this app with any user in your company so that they can give you feedback. So let me fast forward a little bit. I've shared the app with several folks on our research team so they can try out a variety of different questions. And under the hood, what happens here is that every single request is being logged through inference tables into a Delta table in your system. And so in this case, the question, what is DSPy? The full trace of what happened in the chain. Now, earlier I showed you the chain. It had a generation step. It had a retrieval step. These are all logged here for easy debugging later. Now, in addition to this logs, you have the logs of the human feedback that came through the application. So in this case, you can see what the human feedback was. And one question, it was correct. The one I just marked was wrong. Now, unfortunately, our research team doesn't have a lot of time available. And so I'm not going to be able to have them ask every single possible question and evaluate it. Luckily, the team has built LLM judge models that we expose within our evaluation tools. So what is an LLM judge? An LLM judge is a specially tuned LLM that can help you assess the quality and accuracy of the bot. For example, taking a detailed look to see if it's hallucinating or not hallucinating, like I showed you earlier. Now, our research team, this helps you scale human evaluation by using an LLM to evaluate RAG outputs for quality. Now, these models are validated by our research team. We've validated them on open source data sets and on some customer data sets, and they're incredibly easy to run. So in this case, what I've done is I've created an evaluation set, which is a concept inside the product. Really just a set of questions that we expect users to ask about the bot. I could have optionally attached ground truth, but I don't need to. And what I'm going to do is I'm going to come over here and I'm going to run the various different judges on top of this. In specific, I'm going to look at the faithfulness. Is the bot hallucinating? This is simple. I just call evaluate. I pass in that table I showed you, and I pass in the version of the model. I'll first run it with the first version. Now, let me come over here and I'll look at our dashboard. This is automatically generated, both offline and online. And you can see it helps you answer questions like, how performant is the model? What's its cost? How relevant are the retrievals? How are the generations doing? Are they harmful? Let's focus on that faithfulness or hallucination. So you can see, I got one question. We're at about 55%. That's not great. Half the time we're hallucinating. So what are we going to do? So in the background, I actually kind of dug a little bit more into what was happening. And what I realized was that I needed to adjust the model's prompt. I did this by looking at some of the different aspects. And I wanted to tweak the retrieval strategy as well. So I've gone, and in interest of time, I've actually deployed already the next version of the application, again, using these same things. And we can see this here deployed in another window. I can say, what is Aries? And in this case, it's not hallucinating. A retrieval augmented generation system. Great. So now what I'm going to do, this is just a one-off ad hoc thing. So let me come back over here. I'm going to adjust my judge configuration. I'm going to evaluate both version 1 and 2. And I'll come over to the dashboard that's generated. And I'll look. And I can see my faithfulness metric here. I can see it's gone up to 83%. For me, I'm ready to deploy this out to production. And so the best part of all of this is while I showed you this chain code and the configuration in a notebook, I can just check those artifacts into Git. I can run a CI/CD workflow, including the offline evaluation, and deploy this directly into production. So in summary, it's a preview of our workflow and evaluation tool, built specifically to help you build high-quality RAG applications. If you're interested in joining the private preview, please scan the QR code or go to the link on your screen so you can register your interest.